Hello, so we are back at this time. We have a proper nice laptop, huh? Stay spooky. So this is a Clevo laptop, i7 Gen and NVIDIA graphics, a gaming laptop. Now this job is coming from a computer business, and they are saying tested incoming power on the back of the charging port, remove the motherboard, look for burn or missing components, but found no visible damage. The owner charger was bad, so I assumed that had something to do with the issue. I replaced the power adapter, but the laptop still won't charge or power on. So the laptop is dead. I will say before we are plugging the power, because we don't know if the motherboard is shorted or not, the main power rail. I will say let's open the laptop and try to have a look inside. Let me check on this battery. Huh? What is this? Yeah, okay. Just give me like 1 minute. Let me open the laptop. And the laptop, it's open. Okay, that's a nice motherboard. Huh? It is a nice one. Proper solid heatsink. So what we are checking first? First, we are checking the main power rail to find out if it's shorted or not. So, I mean, look here, the configuration is quite simple. Charging port, first MOSFET, second MOSFET, current sensor, you can see. So checking on the current sensor, and we have 1 ohm. Check on the screen, 1 ohm. That means the main power rail, it is shorted, and that's bad. What can be shorted? It's 1 ohm. 1 ohm can be anything. Yeah, probably not the VRAM, but it can be the GPU MOSFET, a GPU MOSFET, or a CPU MOSFET. I had one like this a few days ago, and it was a CPU MOSFET. But anyway, let's take out the heatsink and check. You know what? I will be honest with you. I do like the design. I mean, check here. You have the heatsink, but also the cover of the fan is like copper and is part of the heatsink. I mean, clearly this is more efficient compared with like this fan. Yeah, so this is more efficient just because even this part is getting hot, and of course the air is flowing. Yeah, proper nice design. Okay, so we have no heatsink. You know what? I'm gonna go straight to the CPU just because I had, like I said, a few days ago I had one. I had one with this coil shorted. So this coil to ground, and it's like 3 ohms. Okay, this is not that one. CPU 3 ohms, 3 ohms, 3 ohms. Now the main power rail to this coil, 3 ohms, 3 ohms. You know what? It's not the CPU. No, it's not the CPU. The VRAM 34 ohms, so it's not the VRAM. The GPU, we can't really figure it out. The GPU. No. The chipset. The chipset is good. So what can be faulty here? 8 ohms. What can be faulty here? Yeah. 1 second. So here is like one power rail, and this one is coming on when the CPU is raising the clock. Yeah, and it's fine. So you have one power rail created by 4 coils and one power rail here, and probably here is the chipset, and it's fine. Okay, so you know what? Those are kind of like good news. I mean, the CPU is not dead. If the GPU is dead, we can still disable the GPU and the laptop will work on Intel graphics. On this point, yeah, we can hope, yeah, but only we can hope for a shorted capacitor. Yeah, can be. I mean, if it's not the CPU, it's fine, yeah? Can be anything else. And also not the chipset. So let me bring my thermal camera. So I'm gonna lower the voltage on the power supply, like 0.8 volts, 0.7 is fine. We need a ground, and this is a good ground, and that will come with the current exactly on the main power rail. And it's taking nothing. Wait, this is not ground? Yeah, it's not ground. Okay, that's a good ground. So it's taking like 600. No, this is not a capacitor. No. Or it's a capacitor with a very high internal resistance. I mean, the internal resistance is quite high of this short. So, place your bet. The GPU? No, it's not the CPU. No, the CPU is fine. GPU looks warm. Huh? Check that. Well, maybe it's not the GPU. Maybe something else. We are missing something? No. What is that? A GPU MOSFET. I can't believe. 1 second. So it's the second one, right? Yeah, the second MOSFET. Check that you have the coils. Yeah. Yeah. This one. I think it is possible because I see in this laptop it's using that monolithic drivers. They have catastrophic failure detection or something like that. And basically, what happened? Whatever is going wrong, the chip it will switch the low side MOSFET. It will switch on, with the risk of getting shorted, of course, but it will prevent the output. So it is possible the GPU to survive. Yeah, check that. A694. Hmm? You know what? Hmm. 1 second. We seen the GPU getting hot. It's very important to understand the fault. We have to be sure the GPU is getting hot also. Huh? So coming here, I'm gonna, yeah, like 1 volt. Yeah, so it's taking 1 amp. I'm gonna short the output to ground just to see if the high side MOSFET is shorted on that DRMOS. It is going up. Yeah, the current is going up. You can see 1.2, taking the tweezer 1.8. Feels bad, man. Okay. So I'm assuming the GPU most likely it is dead. I mean, hard to say because the GPU has a very low resistance. And if the resistance is very low, that means it will take a lot of current. That means it can trigger the protection with from the input. But not sure. Let's remove the DRMOS. I do have this DRMOS, but I'm not going to replace it. The GPU should work fine without this. I mean, all those coils and chips are on the parallel mode. So even if we are removing one power supply, should work on the other. I mean, here is on flux, so it is possible someone were here. And the chip, it's out. Yeah. Okay. So we remove the chip. Do we still have a short on the main power rail? The main power rail to ground is not shorted anymore. Yeah, so we remove the short. I will say, let's test it. If the GPU is still good, I'm gonna replace the MOSFET. But maybe I was a little bit overconfident regarding these monolithic drivers. Looks like this one, the high side was shorted and the low side didn't short the output to ground. Or maybe it was supposed to short the output after a certain because we didn't push the power supply to, let's say, like normal use. Probably on that GPU we should have like max 1.2 volts. So if I will push like over 1.2 on the main power rail, that burn the RMOS, it will do the job? Not sure. But let's see. Means the GPU should be good if that chip, did the job. Wait a little bit. We need a charger. So we have the charger, 19 volts on the power supply. Yeah, we need a bunch of current. Yeah, like 4 point something. Good. Plug in the charger, and the laptop is taking like 10 milliamps, which is fine. Pressing the power button and the laptop, it is coming on. It's taking like 2.8 amps. I'm assuming someone reset the BIOS, so we have to wait a little bit. Oh, the hard drive is making noise, not the fans. So the laptop restart, which is fine. Yeah, that's good. Means it's not like a brain dead laptop. 3.2 amps. We have picture. Huh? First boot or NVRAM. Okay. Okay, press OK. I mean, don't get me wrong, this has switching graphics. So just because you see picture on the screen, that doesn't mean the NVIDIA chip is working, because when the laptop is start, it works on Intel. The laptop, it will switch to NVIDIA only when the Intel get like fully loaded. You open a game, okay, the Intel goes to 100%, it's switching to NVIDIA chip. So just because you see in picture doesn't mean it's working. Yeah, the laptop shut down because I don't have enough current. I do have a charger. Yeah, let me plug a charger, a proper one. So plug in like a 10 amps charger. Okay, the Windows is loaded. Yeah, we do have a password. Let me switch to my my SSD. Yeah, that's my SSD. Good. Let's try one more time. So on Windows, the GPU is there. You can see RTX 2060. Now let's check if indeed it's working. I can't believe it's working. So check here, you can see we have the RTX 2060, GPU load 96%, everything is working fine. It's taking power. This is crazy. I mean, check that the clock is present, everything is fine. Ha! This is unbelievable. So actually the GPU survive. In the moment you take the load out, you can see everything goes to zero because it's switching to Intel. And now the laptop is working on Intel graphics. That's how the switching graphics works. And the NVIDIA, it will be dead. I mean, it will have no power, no clock, nothing till the moment you stress the Intel. So if we're trying to, whatever you do, whatever you try to do, like a render test, that quickly it will fill up the Intel, and then the laptop, the NVIDIA chip, it will take the load. That's how the switching graphics, gaming laptops are working, and all are switching graphics. The thing is, no point running the laptop on NVIDIA when actually you don't play a game. And most of the time, you don't play a game, even if you have a gaming laptop. Usually, you do like browsing and stuff. Then, on some point, you start playing. You got bored, then browsing again. So yeah, most of the time, you don't really need the NVIDIA GPU, but it's working fine. Now, if you ask, okay, sorry, but you remove a MOSFET, you know what I mean? They put a MOSFET for nothing there, or what's the story? Well, the thing is same like with the fuel tank at the car, yeah? On a car. It show you have 5 liters remaining. There are no 5 liters. You can see there are 5 liters, but after you finish the 5 liters, then you have probably 1 more liter. So same here, yeah? I mean, if you need like 50 amps, most likely this GPU is taking 50 amps, 50. They don't fit 50 amps power supplies. They fit probably like 70 amps. Yeah. So 70 amps power supplies running at 50 amps, they are more relaxed. So the laptop life is longer. That's the reason why the GPU is working even without that DRMOS. Now, of course, it is some pressure on the left DRMOS from the power supply. That's why we will gonna replace, actually not replace because we remove it. We're gonna fit the DRMOS there. A brand new one, of course, of course. Now another question from people more advanced into the repairs. It will be, okay, sorry, but I mean, this is like a proper advanced DRMOS. Doesn't have like a power good pin, and they do have, but the problem is the power good pin is hold high. If something goes wrong, that pin is dragged down by the chip. Basically, if it's not chip, the power good signal is okay. Now let me quickly grab a brand new chip so we can replace it. And I believe we found it. Switching to microscope, check there, yeah? A694, same like the original one. A694, huh? Exactly the same chip. Perfect, perfect. What did you say? No brand. Yeah, it is brand new. That's how I'm holding the chips. Yeah, soldered on the boards. It is a brand new. We're gonna sell this chip as brand new. Yeah. This is not the same. That's crazy. Okay, I need a longer chip. Are two versions of this chip, yeah? Shorter and longer. Oh, that sucks. So check here. We cannot solder this chip. It's the same chip, but has in a different capsule. And I believe I have the biggest one on my box. Yeah, I'm pretty sure I have it somewhere. Yeah, let me find it. It's here. I know it's here. I feel it. Check that. I can see it. I can see it. Check that. Ha ha. Another brand new IC. I can't believe. Yeah, that's the one. So you see, it's exactly the same chip. Wait, this is brand new. I mean, that pin is no solder. Yeah, that pin has no solder on it. Perfect. Check there. Yeah, that's how a brand new chip looks like. Yeah, it is soldered properly. Good. So we soldered the chip. I believe this laptop is repaired. Hmm? What do you think? Let me quickly clean it and apply some thermal paste. Now, one more time, I am impressed by these monolithic drivers. We found a Dell laptop with this monolithic driver, exactly the same one, shorted on the CPU, and the CPU was still good. Then, if I remember, it was a Asus laptop, like a normal laptop, still the same CPU DRMOS, and the CPU was still good. So I'm quite impressed about this monolithic driver. So this is the third laptop having this exactly this chip, and actually, okay, the chip is gone, but the output survived, the CPU or GPU. Pressing the power button and the laptop, it is coming on. We didn't unplug the BIOS battery, that means the laptop should come on straight away, and it is coming on. Yeah, loading the windows. Let's start the render test. And yeah, it's working fine. Yeah, all good. So what do you think? It's getting quickly hot. Temperature is rising. 62 degrees, it's a decent temperature. We just replaced the thermal paste. But yeah, it's looking fine. Perfect. I'm happy I helped this customer. I'm gonna stop now. I will say thank you for watching. Like, subscribe if you like the video, like always, and see you on the next one. Bye.